You probably know about and really like using list comprehensions in Python. This week I want to show you another piece of syntax that you can use that's very, very similar to create generators and talk about why we might do that. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. We've talked a little bit about generators in the past and using next and yield, but what I really haven't talked about is how to create a generator object in a list comprehension-like way and why we might want to do that. So let's take a look at a couple of examples here and see what the advantages are, because it's not really going to be a speed advantage in the end, and why you might want to do this. So first I'm going to use the time magic, and let's call this squares list. I'm going to use a list comprehension, s to the power of 2 for s in range, and let's go with something pretty large, like 5 million. And let's see how long that takes to compute. Okay, so wall time was 1.5 seconds, CPU time is about half a second. Now we could use timeit or some more advanced utility, but I'm not really focused on time efficiency in this video. What I instead want to show is memory efficiency, because that's where generators on something like this can really step in and save the day. In fact, if we were to look at squares list, let's just verify that it is indeed a list like we expect. There we go, the squares of 0 through 9. Now let's import sys, and let's use sys.getSizeOf, which shows us the size of in bytes an object in memory, our squares list. That's pretty large. In fact, if we wanted to get that in kilobytes or in megabytes, we could just keep dividing by 1024. That's 42 megs of our system RAM. This is a relatively small list because I'm just using it as a demonstration here, but you can see how if you were creating some very large iterable that you were then going to step through, this could take significant amounts of RAM on your system, and that may just not work out for what you're trying to do. Well, we can instead use a generator and generate those squares one at a time. Now again, we still have to do the computation, so it's not like we're magically getting CPU cycles back, but we're not putting all of this into RAM, and we're not using all those CPU cycles at once. We're just using them when we need them. So to do that, and this is where it's really quite nice, Python syntax was well thought out here. I'm going to copy and paste that, change the name to generator, and replace the square brackets with parentheses. Now remember, there are dictionary comprehensions, list comprehensions. This isn't really a set comprehension, which is what you might expect, or a tuple comprehension or something like that. It makes a generator. In fact, if we try to print it out, we just see it's a generator object, and we see the time was 0 nanoseconds. Well, okay, that's probably not quite true, but it's much smaller than what time can measure. It's practically instantaneous. Now, why is that? Well, it's because we only created the generator object. We haven't calculated the squares of anything yet. If I wanted, I could call next squares generator and just keep calling it. And we see that each time it gets the next square because it evaluates the generator for the next value. So we're not taking much RAM at all, and we're not taking a big block of CPU time at once. Okay, well, let's look at the size of, using sys.getSizeOf, our squares generator. 104 bytes, because really all it's storing is the operation that's being done and the last value that was computed, or the last value that was computed for. So when we call next, it knows what the next value is going to be. So while the concept of generators has been around quite a while, and we've talked about it, I've always written a function with a yield and used that to make my generators. But this piece of syntax right here is just really nice and convenient. Again, all we're doing is taking our list comprehension and replacing the square brackets with those parentheses to create our generator object. Again, this is a great way, especially if you're doing large computations on many data that you're iterating through, to free up some of that RAM on your system. I hope that you found this tip useful, and I'll see you on next week's MetPy Monday.